Okay. All right, it's the time to have our class. And let me share the screen first. Right? So it's your Jun Kai's turn to do the presentation. Okay? And I already do this download this one. Okay? And yeah.
Hello, everyone.
Hello.
Hello. Can you hear me? Yeah. So I'd like to explain my answer. So first question, the question is, do the estimated coefficient support our expectation? So firstly, my expectation was a teacher who provide easy question to the student, yeah, can get high ratings. And I also think the teacher who is considered like attractive might get good ratings. And then when I take a look the equation on the textbook and the result, what that I get from the EDUs, both have a positive relationship, as you can see. And then at the time, I thought like since the size of coefficient of hot is much bigger than the size of coefficient of ease, so I thought like teacher who is considered as attractive can more get ratings at first. But after that I realized also I listened to the other student. I realized that there are only two variables, which is the ease and the hot. But since it's about teaching ratings, so there are more important things should be included. So such as yeah, the content of the lecture, the teaching attitude should be included for more specific result. My answer for question A. So question B is this one, and about the question C. The question was, does it depend on only two variables? As I mentioned in the first question, my answer is no. The things that influence on the teaching ratings can include the content of the lecture, of course, more interesting content attract the student attention, and the teaching attitudes. If the teacher's attitude is so bad, the teacher doesn't want to take his or her class again, right? And then teacher's enthusiasm is also same. So communication skills, yeah. In terms of teaching, so communication skills is one of the most important skills. Yeah, so it should be included as well. Then question B. The question was, oh yeah, if I add a new variable, yeah, I think the coefficient of V and the coefficient of hot is going to be changed because yeah, adding more variables will distract other variables in the regression line. Yes.
Let me ask you one question here. Talking about the coefficient of the hot and ease, okay, let's move to the upper parts, okay? Okay. We do have the coefficient of ease is 0.01, okay? And hot is 0.59. And I think Jin had just say that the coefficient of hot 0.59 is bigger than the coefficient of hot 0.01.
Yeah.
So any indication about this one?
No, actually, I found this one is kind of mistake because I mean, the way to evaluate those two are completely different. So
Yeah, so what I'm saying is the size of the coefficient. One of them is just 0.01. The other one is 0.59. Although the 0.59 is larger than 0.01, does this do this coefficients comparable?
I think I'm comparing.
Are these two coefficients comparable? Why or why not? What the reason? Do you know the reason? Can we directly compare the size of the coefficient of these two variables? That means that are we able to just compare 0.59 is bigger than 0.01 and they something about it. Can we do that? Why or why not? Do you know the answer?
My answer is uncomparable.
It's not comparable.
Yeah.
Why?
But because I remember one is 0 to 1, and one is 1 to 5. So can be compared.
Very good.
Yeah.
Very good. So the measurement units for these two variables are different. Therefore, the size of the coefficients are not comparable. You know what I'm thinking? And I think Jun just says it, right? He just says it, right? Since the size, since the measurement unit for ease is from 1 to 5.
Yeah.
Okay. Then hot is from 0 to 1. Okay. So they are not comparable. The measurement units are different. Therefore, the size of the coefficient cannot comparable. Okay. All right. Thank you very much. Yes.
So you mean that if the measurement is the same, then it's comparable?
The two measurement units are the same. So for example, so in terms of pounds or dollars or something, then, it can be comparable. Otherwise, no. And most of the situation, in the multiple regressions, we do have different measurement units for every individual. Therefore, most of the time, they are not comparable. All right? I think this is very important points. Okay, you have to understand, okay? Keep it in mind. All right? Okay, thank you very much. All right? Any other questions? No. All right, so now it's Rachel. It's your turn. Okay. This is good.
Thank you. Good morning, everyone. Today I'm going
Just
to.
say it loud.
Okay. Good morning, everyone. Today I'm gonna present about my work. Um, for the question A. From the coefficients above, we can see that variable is, which is x1 increase, so the rating y will increase to n. Before we see the equation here, I'm thinking that the more is the professor giving to the students, the rating of the professor will increase too. For the whole, the more attractive the professor is, will increase the rating too. Like how the professor manage their self when teach the student, like um, looking professional look, like like professional look when teach the student. So in addition to that, if how our x2 increases, so the rating of y will increase too. It means that y has a positive relations with x1 and x2. And I just think that we can also see that thought has a higher multiple constant than is, hence meaning that variable thought has higher impact on rating than is confirming our expectation. But professor just confirming that these two variables, these two dependent variables has nothing to do with which one is higher. So I think my thought was wrong before, but now I can understand more. And for question B, okay, this is the so for every point increase in how easy the professor teach, the rating will increase by 0.01 point, holding constant how the professor is. Okay. For question C, it makes sense to think from two variables, but we can also add more variables into the equations to see from another factors. For example, it could be the knowledge of the professor, and communication skill, like how the professor teaching, the way professor teaching and organization experience, also teaching experience, like the more experience the professor is, will also have relations with learning. And for questions, we think that variable thought will decrease because the variable only shows yes or no, or means one is yes and zero is otherwise. And also the coefficient is already low. It might go up if we add some variables into the equations, but I didn't really pass into the equations. So we would expect the other variables such as listed in answer C to potentially have a greater impact on rating than thought and is, hence widening the spectrum of relevant variables changing the relative influence of each variable on rating.
Okay, I think Rachel mentioned, okay, the variable, the part shows only yes or no. Yes means one, zero, no means zero. Okay, so this is really different definition of the variable. We call this variable is like categorical data. It's not numerical data. Okay, for hat is really the value is really from 0 to 5. So all these numbers, all these numbers, all these values is what we call numerical value. However, the fact is just 0 and 1. Okay, then this is what I'm going to cover this one in chapter 3. Okay, this is really totally different though. Okay, and we will explain it in different way as the variable, as a numerical variable. Oh, this is one point I want to mention, since, Rachel, mentioned this variable is yes or no only. Okay, all right, then, move back to the equations. I'd like to ask all of you, do you know how to make the equations in Word file? Do you know that? If you do this way, you didn't really use the equation function, right? Do you know how to do that?
Yeah, actually, yeah,
Do you know how to do that? If you don't know, I can show you. I can show you how to do it. And in the future, please do that. Okay, since this is the regression analysis class, all the mathematical equations, you have to express it, write it in equation way instead of like this. Okay, this is not the question. Okay, so I wanted all of you in the future, when you turn in the homework, all the equations, you need to use in the equation form, the function equation. Okay, I think we have a little bit of time. Let me just quickly show you how to do it. It's not difficult. Okay. Okay. So thank you very much. Okay. Let me just show you how to do it. I'm just using Rachel's file to make this 1.22 as a professional equation. Okay. All right. Let me do this with you. One of the teaching job I have to do in this class. Okay. Do you all know this function called this one is called insert? Okay. I don't know whether you read Chinese or not, but for Word file, I think I just have the Chinese versions. Okay. So I'm going to explain it in this way. Okay. This is a function of insert. After you get this insert, look at the upper corner, right upper corner, there's a called function. Did you see that? Did you see that? So here's the function. And this is all mathematical functions we need. So we need to do the rating, I, right? So in other words, I have the subscript. Okay? So using this function, either this is superscript, the subscript, any kinds of mathematical expressions. So far I need to use this one. So I hit that function, then I type rating, then move to this box, then put the equation. So this is the difference from what we have over there. That's just regular typing, and this is just equation. Okay. Now, if I wanted to have those ones, so suppose you need to have the model, the correct calculation model. Okay. So again, we're working with this one. Now you need to have parameters, which is Greek letters. Okay. Look at the sign here. You see all this, I need data. Okay, then What is this one? So again, beta one. Form. To the another is I and hot I. Okay. So I need an arrow. Then arrow terms, which is this one, okay? One, and back to here. So is this one. All right, this is the equation form. Okay, so in the future, please write down in this equation form for all the homework, okay? All right, is it that easy? After you have this one, so you need to, another equation, you can just copy it, right? So just copy it. You can copy it. Then paste. Okay, then change the variable. That'll be fine. All right? So it's not difficult at all. Okay, let me erase this in. Rachel's homework. Okay. Right, then, whose turn? Now it's Vicky. Hello. Speak louder. What's the energy, okay?
Today I'm going to present my work, and for question number 8, my answer is yes. We know that these and how well that the result of rating, the easier the professor is, the higher the point he or she will get. And the overall rating is 5. And even if the professor is not that easy, the point will not be negative. Also, hard only have 2 results. If the professor is tough, then he or she will get 1. If not, she or he will get 0. So the result again is positive. And in this case, I think the equation should be positive. And that's why I think it support our implementation. And answer for B is over here. And for C, in my opinion, the personality of professor and whether the course content is interesting or not will affect the result.
these are the two of the variable that I think might be important. And for B, I expect the coefficient of E and half and might slightly change because add more variable. But it won't change much. Also, I think the result will still be positive, and these are the rating at time profile. The personality of the professor, if the student regard professor's personality is good, then the rating will increase. And whether the course content are interesting or not, from 1 to 5, the more interesting the course is, the higher the rate is. And thank you for your attention.
Okay. Okay, I think that, Vicky brings up, the definition of the new variables. For example, she likes to use the one with, professor personality, which is also 0 and 1. And that is what we say is the same as the one with the hat, right? Is that we call it a categorical rule. And the other one is, whether the course content is interesting. And you scale it from 1 to 5. So this is another numerical variable. Okay, and you're thinking that the two variables has positive relationship with the rating of the professor. Okay, all right, good. And anything else? Okay, I think I mentioned quite a bit about the related topic. Okay, so now let's turn to the tablet. Those who didn't do the presentation, I will read your assignments by myself. Okay, then so everybody has I won't read everybody's homework. Okay, but those already do the presentations of I already seen your assignment. But those who doesn't or who then I will read it myself. Okay, so don't worry about it. But those who do the presentation, you have another presentation performance. Okay, so you have the scores about presentation, the performance of presentation. And everybody has your homework grades. Okay, all right. Then let's see. So it's Kevin.
I am Kevin, and I will report my assignment. And question A, I expect the coefficient of these and how in this equation to be positive. And according to regression results, there are two positive coefficients on this data result, which are in line with our expectation. And yeah. This is the result.
Okay, let me see your questions. This is very good, very typical question forms. Okay, so you will also want to do this also using the functions inside the application function. Okay, you can choose the hack function. Very good.
And this is the result of running the E. We can see the coefficients of E and half are consistent with another equation. 1.25. Yeah. And question C. I think only two variables determine the professor's rating is not objective enough. I think the professor's field of his expertise should be considered as well. I say that professional knowledge is positive or related because the higher the professionalism of the professor, the higher the rating. And question E. Maybe the coefficient of these and outs will change as adding the new variable. As for the delta change, need to be judged by the reversion, and I also hope that it will not change because that will make this situation more complicated. Thank you.
Okay, thank you very much. Let me also say something that, if you add one or two more, I mean, a new variable into the equation, okay? If those variables are very good, and now is omitted from the equation, then, of course, that will have a big impact to the result of the equation. Okay, I mean, the big impact, not only the size of the coefficient, but also other, estimates. Okay, maybe you will see that so far, since we haven't really learned it yet. Okay, so how do those new variables affect the old variables already included in the equation? It depends on the relationship with the new variable with the old variable. Also, the new variable with the y variable. So, like Calvin said, it may be very complicated. It will cover this one, this method. Even, so far, we are just talking about the size and also the directions of the variables to the y. We didn't really say these two variables importance. We haven't said the importance of these two variables. I mean, height and easy. If we go to the chapter 5, which cover hypothesis testing, in that case, then we will talk about how important these two variables will affect the y variable. So far, we didn't really talk about that. We didn't say the importance of these two variables. We're just thinking about, can you think about what kind of variable, what kind of factors will affect the performance of the professor only? Okay, so now we're just very creative to think what kind of variable is possible to affect the teacher's performance. So like the one, just math just mention one, which is the interaction of the two old variables, and make this one as a new variable and include it in the equation, and together, what kind of result or what the consequence will be for this new output, new result. Okay, so that's a lot of things we will learn gradually in this semester. Okay, all right, thank you. Then, who's turn now? Well, now is the teacher. This is yours, right?
Yes.
This is, no.
Good afternoon from Tom and all friends here. Today I will try to present what the result of our group discussion. For the question A, as we discussed before, we also expect that the vote will increase the rating. Then we say that because of votes of the coefficient are positive, therefore it is support our expectation. The explanation of the equation is the overall rating will increase by 0.59 point if the professor is considered to be holding constant its rating, and the overall rating will increase by 0.01 point for 1 unit increase in its scale, as we know that in its scale there is 5 units from 1 to 5. If the difficulty level and the workload of the task are considerably easy, holding constant the rating. And therefore, based on this data and equation only, we could conclude that the estimated coefficients support our expectation and also support the article. Being hot improves the professor's rating more than being easy. But as Prof. Kao said, that it is not directly comparable actually. But at first we think that it is support also the article, and the 0.59 is higher than 0.01. We added that, but the statistical significance of that estimate will have to be investigated further before such a conclusion could be justified.
So in this case, sorry, I was thinking about, according to the article, the variable cost input the professor rating more than being easy.
Yes, there is.
According to the article,
Yes, the article mentioned in the question.
okay? So you're thinking that, the result from, our data really support the article. Because
Yes.
0.59 is greater than 0.01.
Yes. At first we think like this, but we are not really comparing the unit measurement.
Okay.
And this is, as we need to verify the data, we input the data, and we input the data to eViews program, and this is what we got. The intercept is the same, 3.23, and for hot is also the same, 0.59. There is a little bit different in each coefficients, as in the equation it is rounded up to 2 decimals, so from 0.006 up to 0.01. And for question number C, we think there is another possible variables that could be added in the equation. Like the first one is education, maybe the university background that the professor attended before. And the second one is achievement, maybe like the quantity or the quality of the published paper or journal. And the knowledge, of course, in the field that the professor teach. Also including whether the professor is up to date or not. Maybe if there is a new trend in the field, the professor is up to date or not. And soft skills like communication skills, problem solving, and integrity, and patience, either in teaching us, the student, or towards the field. And for question B, based on our discussion, our answer is yes. We think if we add new variable, then the coefficients of is and hot will change. We make several conditions. The first one, if the new variable is significantly correlated with y, then we get the coefficients of hot and is will also change significantly. And the other condition, if the new variable is not significantly correlated with y, then the coefficients will not change significantly. And besides, if the new variable is correlated with the existing x variable, even though it is not directly correlated with y, then it will also affect the coefficient. I think that's all the result of our discussion. Thank you.
Okay, I think the key part is what, gradually we will learn how all these new variables affect, the old variables already included in the model. Okay, Okay, the last one will be function.
Hi, everyone.
Hi, everyone.
For the first question, my answer is yes. The estimate completion support the expectation because both risk and cost are positive. But however, the completion of cost will be more efficient for professional professor rating than the coefficient of risk and the next.
This is correct. However, the position of hat will be more exacting than for professional rating than the position of his exam. Which means, I mean, is this one correct?
Yes. For, I mean, that is and must both are positive. Is indicate that we must improve professor rating more than we.
I mean, 0.59 is compared with 0.01. This one is bigger, so the effective is, more effective. So hot is more effective than is, than is.
That is it.
Now, we just say that this measurement units are different. So they're not comparable. You may not say so in this one.
We cannot say it's safe.
Yeah, we cannot say so. So far, we cannot say so, okay? All right?
And for the next one, for the next one, after a year, in the program for running the data, and the result is same as the equation 1.25.
Let me see the answer. Okay, correct.
This and one.
Okay.
For the station thing, for my opinion, it doesn't make sense. Or that, for the teaching rating of our professor can be more variable. It's not depend on just must and receive. For my opinion, other important variable might be consent and control, teaching aid, communication, maybe. For the last question, if I ask my success variable to equation 1.25, I think the coefficient of this and what will be changed. I think it may be increase or decrease because um, other variable will be effective more than responsibility.
Yeah, correct? Understand. All right, so that's it?
Yeah.
Yeah, okay. Okay, thank you very much. I think all the students do the presentation. All right, I think this is our first assignments, and I'll let everybody, every student to just have the feeling of our class assignments for this semester. You know, so far we're running in this way, okay? And our second assignment is coming too. Okay, would you please turn to the page of chapter 2? And I'll finish chapter 2 today. Okay, so our next assignment is due 2 weeks from now, so which is 20th, October 20th. Okay, and what is our assignment? Do please turn to the page of 81, 2.7. This is appendix about econometric lab number 1. Okay, this semester we're going to work with 4 labs. Okay, which will go by chapters. Okay, so the first lab is go with chapter 2. And in this assignments, look at page 81 and 82. We have from step 1 to step 6. Okay, this one is not very difficult either, but in this assignment, you have to collect the data by yourself. And what kind of data you're going to collect? Okay, did you remember the height and weight data example we used in chapter 1? Okay, I'm asking you, every one of you, to collect 50 students, 50, 50, weight and height, and also the gender. Okay, any problem with that? 50 students. Any problem with that? I think it's okay, right? You can ask your friend. Okay, all right? And so I need to have 3 variables. 1 variable, again, same as our example, okay, which is the height. Okay, and now since we're in Taiwan, so maybe the lens height is in terms of centimeters instead of inches, right? So just use centimeter as centimeters. And in our example, they say it's above 5 feet, right? So for in terms of centimeters, you need to minus 150. 5 feet is equal to 150 centimeters. Okay, so ask your friends or the other students' height. Okay, subtract 50 centimeters. The left will be your y variable. Okay, if one of the students 180, then you will collect data with 30 equal. Understand what I'm saying here? And weight. No, in Taiwan, it's kilogram. Kilogram, kg. Kilogram, right? Kg. So just use the kg. Okay. In our example, they're using pounds. We didn't use pounds in Taiwan. So just use kilogram. Okay. Then gender, either male or female. So that is the 1 or 0. Going to use that one to do the expression, later it should be 3. Okay?
But when do you have to get all the data?
Well, since the second due is 20.
26. Oh,
No, 20. Today is 6, 2 weeks from now. It's 20.
wait. Oh, yeah, because next week's,
So you can collect data anytime, for you to, do the assignments anytime. Okay? Alright? And this is the first step. Then follow the second step up to the sixth step to do all the assignments about lab, okay? Alright? Understand the next class assignment two, due October 20th. Okay? Alright, let's stop here for a while and we'll come back.